Okay, students, so now what you are seeing is basically the different components of your quantum eraser experiment, which have been already set up. So the basic thing here is this this is like a metal, sort of a thick metal sheet which has holes for attaching screws. So this is called a breadboard. Okay, so now you are seeing like different components which has been fixed by screws. If you can see, there is a screw which you can fix different sort of optical components on this breadboard, and then you can conduct whatever experiment you want. So these are like the screws that goes into the system. All right, now so what are the different components here? So the first thing is the laser, which is emitting the lights. Okay, so this emits a green light around 540 nanometers. Okay, so this is a diode laser. This is the controller for the laser. Okay, so this one is the driver for the laser. After that, so this one you see is a basically magnifying glass, which you probably cannot see the screens now where the light is falling. So this basically, the beam of the laser is like a very fine sort of a few millimeter dot. So this fringes will be produced in that very small area, so you have to for better visibility you have to expand it. So this magnifying glass sort of diverges that beam and increases the size of the spectrum, fringes or spectrum. All right, now then you have this beam splitter, which basically can split the beam. That means when the light is falling on this splitter, partially the light gets reflected, partially the light goes through it. So this is a very fine metal coating, very thin metal coating, so it can achieve that. Okay. Now you see what it does is it divides the incident beam into two different beams, right? So now there is a two distinct path that the light takes after hitting this beam splitter. So one goes along this, another goes along this. Okay. So there are two distinct paths now. Now the next component here is a polarizer. So what are the different roles of these things? Why we are using all these things? You will know when you see the video for the experiment and you read the manual. So this one is for polarizing light. So I'll discuss what its importance is when I discuss the experiment. So now if you see that there is also a sort of a glass-like material which is basically the polarizer, which can, once the light passes through this one, the electric field in the light is pointing to one specific direction, which is called the transmission axis or the pass axis of this polarizer. So there is a way to sort of rotate the crystal, the polarizing crystal here, using a knob that is given here. So you can rotate it. That means you will be changing the direction of the polarization of the light that passes through this one, right? You can read what angle you are rotating this thing from. There is a small vernier scale and there is a circular scale from 0 to 360 degree attached on this rotating knob. Okay. So you can measure the angle actually. Okay. So you can keep track of how much you are rotating, which polarizer is what angle, you can find out. So this is one polarizer, this is second polarizer. There is a third polarizer in the experiment as well, which you put just before the your screen. This is the third polarizer here in this experiment. Okay. So you have to put them in specific rotation. So if you go to the manual, you know what are the rotation, specific directions, so that they polarize the light in specific directions. So this is one polarizer in one of the path of the light. The second path of the light also has another polarizer which polarizes in a different direction. You basically will set them to 90 degrees to each other. So they will polarize the light. Light coming from these two paths will be perpendicularly polarized to each other. Okay. All right. So light goes through the beam splitter, through the polarizer. This is a mirror. Okay. So this basically reflects the light towards this direction, so 90 degree. All right, so light go. This is the path 1. Okay. Next, you see the path 2. There at this beam splitter, there it is divided into two paths, right? 1, 2. So this path goes through here. This one is a mirror. So again, it reflects it back in this direction. So it goes there, it gets reflected, goes through the polarizer where it attains a particular specific polarization, goes through this beam splitter. Let's say into this screen. So this is screen number 1. Similarly, part of it is reflected and goes to the screen, let's say screen number 2. So again, if you consider the first path, there also the same thing will happen. So light comes here, hits the mirror, goes to this beam splitter. Part of it is reflected and it comes to the screen 1. Part of it is transmitted and goes to the screen 2. Alright. So at this screens, you will be observing your fringes. Alright. So this is the basic setup. So this this what you are seeing is called a Mach-Zehnder interferometer. Okay, without the polarizers, you have the Mach-Zehnder interferometer. All right. So the polarizers are there basically for mimicking the quantum analog experiment. Okay, sorry, quantum eraser experiment. So this is like an analog for the quantum eraser. All right. Okay. This is a classical analog. So actually, this is not a quantum phenomenon that is happening here. Whatever you will be observing, that can be fully explained from classical principles, but there is a similarity with the quantum phenomenon. So we'll discuss that in the next video. What else you need to do? The basic setup of this experiment is quite difficult. In fact, it's ridiculously difficult to perfectly align all these optical components. Okay, because this Mach-Zehnder interferometer is a very sensitive interferometer. So if you have the fringes, even if I'm talking to you for like this, so you will see that the fringes will sort of start disappearing just because of the vibrations in the air. All right. Now, usually you have to do a few things, like you have to check at different locations. For example, light is now coming from the laser light, so you can see from this one. So this one is basically to check the height. So let's say I fix it in a way so that just at the source I see that there is a scale here. So let's say I see that the laser hits at the let's say the zero of the scale. So I move it along the paths at different locations and test whether it is at the same height or not. So there cannot be any sort of difference in height. It has to be perfectly aligned. All right. So there are multiple steps that one needs to take to assure that there is a perfect alignment so that you get a proper fringe. One of the steps is also like you have this, let's say the screen number 1, you take and put it very far away. So even if there is a little bit of misalignment between say this path 1 and this path 2, so if you put it very far away, let's say 6 to 9 feet, so you will see that the two beams are actually diverging. It might not be visible right at this screen, but if you push it apart, so then you can bring the two beams at the same spot. How do you do that? Now this is basically two beams with beam from the path 1, beam from the path 2. Okay, so if you notice, all these different optical components have small knobs attached to them. Okay, so these are basically very fine screws that are attached to it, so it can make very fine movements. So for example, if you look at this one, so this is basically for tilting this thing like this. Okay, beam splitter, it will move the beam splitter like this. This one will move the beam splitter like this. Okay, so making very fine adjustments in the beam's height basically. So you can obviously imagine that if you move the beam splitter like this, the beam will the reflected beam will go up, right? So you can change the height and the alignment by making small adjustments. So if it's not just here, it is there in the laser as well. You see the small movements. It is also in the mirror. There are two knobs in the mirror as well, which you can adjust. So all these components have mirrors, alignment, adjustment options. Okay, so you can do that. Alright, so this is the basic setup for the experiment. The next video we will see how you perform the experiment, how you first get the fringes from the Mach-Zehnder using the Mach-Zehnder interferometer. Once you have the fringes, then you have to put the polarizers, and if you put them at 90 degree apart, they will you will see that the fringes disappear. The polarizations, if they are 90 degrees to each other, you will see that both the fringes at both the screens will disappear. But if you now take a third polarizer and put its polarizing axis or transmission axis at around 45 degree to both these polarizers, then you will see the fringes reappear again. So that has an analog with the quantum phenomenon of complementarity. Okay. Alright, so we'll discuss that when we show that video, but this is basic setup of this experiment. Okay. Thank you.